Hey, what's up everyone, and welcome back to another video. In today's video, we're going to build an accountability app. And what this app is going to do is allow a user to deposit some funds and create a task list. And the only way to retrieve those funds back from our smart contract is to complete the task on our list. So you can think of this as a way of building habits, setting goals, but in general, an accountability app. So a quick overview of what we're going to be covering in this video. We're first going to create our very own custom smart contract for our accountability app, which will allow a user to again deposit some funds into the smart contract, create some tasks, and once those tasks are complete, the smart contract will then refund and transfer back the deposited funds back to the wallet address. And once we have our smart contract deployed, we'll then build our front-end application using thirdweb and create an app that will interact with the smart contract that we built. Now, before we get started, let's take a quick look at a demo of the application that we're going to be building. So on my computer here, this is my accountability app. Right now, we just have a connect wallet button. So of course, you do need to be connected with a wallet to get started. So we're going to connect it with our wallet here. And we have our accountability app. Right now, we currently don't have any goals set up. So we need to deposit a fund that will be transferred back to us once we complete all the tasks. So we'll just put 0.05 to start. I deployed this on Mumbai, so we're using Mumbai Matic here. So we got a deposit to start. Transaction will come up. We'll confirm that. Once it has been deposited, you'll see right here, our goal amount is now set to 0.05 Matic, and it says the deposit amount will be transferred back when all tasks are completed. Now, we don't have any tasks set up, so what we're going to do is first create our task. So let's say our first task here is create custom smart contract, and then we'll create this task. We'll confirm the transaction. And you can see our first task right here of create a custom smart contract has been added. We have our little complete or check button here once we complete the task. We can also add more tasks down here. So we can say build app is our second task. So we can add that task in here. Again, confirm the transaction. And there you can see we have added a task, which is our build app. Now, once you've created your task for your accountability app, you can start checking them off as you complete them. So let's just say we created our custom smart contract. So we'll check that off. We will confirm here. And you can see our task has been completed. It's now marked off as green for complete. Now we have one more task, which is build app. And once we complete the final task, because all tasks are complete, we'll be transferred back our 0.05 Matic that we deposited in the beginning. So you can see right now, currently I have 6.933 Matic in my wallet. And once we complete our last task here, confirm the transaction, you can now see we have 6.9833 because we were refunded back and transferred back the original deposit that we made. And we start back at the beginning where we don't have any goals set, and we can now deposit amount again and create our task again. So there you have it. That was a quick demo of the accountability app that we're going to be building. Again, we're going to start off by building our smart contract, and then we will build our application. So without wasting any time, let's jump back on the computer and start building our smart contract. So let's start building our smart contract first. I'm going to open up my terminal here on my computer, and we're going to create a brand new blank empty smart contract using a thirdweb. And to do that, we can do npx thirdweb at latest, and we're going to do create contract. And this is going to set up our whole environment for us to start building out our smart contract. I'm going to make sure I install the latest packages for thirdweb here. Once that's done, we can name our project here. I'm actually going to just name this goal contract. We can select our framework that we want to use. I'll select Forge for this one. And then we can name our contract here. I'll just name this goal setting contract. Now with thirdweb, you can select from some base contracts like ERC 721, ERC 20, or ERC 1155. But because we're creating our very own custom smart contract, I'm going to select empty contract here, and we're going to start from complete scratch. And once that is done, we can change into our, what do we name it? Go contract. And we can open this up in our code editor. Right, and in our code editor here, we have, our source, under our source folder, we have our contract. So we can open that up really quick. I'm just gonna actually rename this contract as go setting contract. And the first thing we're gonna do for our contract here is set up a structure for our task. So we're gonna create a struct here. And this struct is gonna be for our task. And our task is just going to have two things. The first thing is going to be a string, which is going to be the description of our task. So what is the task? And then the second one is going to be a Boolean, and that's going to be letting us know if the task is completed or not. Sorry, that's just bool. So again, our structure for our task, one, it's going to have a description saying what is our task going to be. Whatever we input in, it will be set as a description. By default, first, our is completed, our Boolean will be false. And as we complete task, we'll be switching over this to true, so we know what tasks have been completed and what hasn't. We'll then create some variables here for our smart contract. The first one we're going to do is we're going to create an array of tasks. And we'll make this public, and we'll just call this task. So again, this is just going to be, this is going to store all the tasks that we create with our smart contract, and that way we can retrieve this array and we can display it in our application. Next, we're going to do uint 256. We'll make this public as well, and this is going to be our deposit. So this is going to be the amount that we deposit into the contract initially, and that we get transferred back after we complete all tasks. And then the last thing we're going to do is an address, which is going to be public, and this is going to be the owner. So for this contract, we're just going to make it so that only the deployer or the owner of the contract can interact with the functions of this contract. We don't want anyone else to be able to create or complete tasks or be able to withdraw deposited funds. For this tutorial, we're going to make it very simple and just make it so that only the owner can interact with this smart contract. Then we're going to create a few events that will emit onto the blockchain as we complete certain things within our smart contract. So the first event we're going to create is task created. This is going to be an event that lets us know the task ID and the description of the task that was created. Then we'll create another event here for task completed. And we don't need to show that is the bool for it. We just need to know what task ID was completed. And then the last one event that we're going to create is deposit withdrawn. And that's just going to let us know the amount that was withdrawn. So once all the goals have been completed and we withdraw our deposit, it'll emit an event to the blockchain letting us know that it has been withdrawn and sent back to the owner. Now, because this is going to be because again, this contract is only going to be allowing the owner or deployer of the contract to interact with it, we're going to create a modifier called only owner. This will allow us to make sure that certain functions can only be called by the owner or the msg.sender, which is going to be the deployer of the contract. And if they aren't, it's going to just notify them and say only the owner can call this function. So for certain functions, we're going to do this only owner so that only, again, the deployer of the contract can create tasks, complete it, and withdraw their funds. And for our constructor, that gets called once when we deploy this smart contract. We are just going to set the owner variable that we set up here to the deployer of the contract, so the msg.sender. Now we can start creating the functions for our smart contract here. The first function we're going to create is the create task function. And this create task function is going to take the description, which is going to be a string. So whatever string we put in of what our task is going to be is what we're going to make our description of our task. It's going to be a public function, but only the owner can call this function here. And what we're going to do is add is add our task here. So we're going to create a new task using our task structure, and we're going to do our description that we are giving into this function here. We're setting the is completed by default to false, and we're going to add it to our task array. And once that has been added, we're going to emit that a task has been created. The ID of the task is going to be the length of the task minus 1. And then we're going to also emit the description of what task was created. Next, we'll create a function for depositing funds. So this is going to be the initial deposit that a user makes when they want to start their goal setting app and task list. So this is going to be a public function. It is going to be payable, because we are going to have to transfer some funds. And again, this is going to be only owner. And the first thing we're going to do is we're going to require that the value being sent is greater than 0. So we're just going to make sure that the msg.value, so the value that is sent, is greater than 0, because you want to hold something within your accountability app so that you can then withdraw it after you complete it. So we're just going to make sure that is greater than 0. And then we're going to make our deposit, so the variable that we sent up here, equal to the msg.value that we send. Now the next function that we're going to create is a safety withdrawal. And this is just in case, and this is just a safety function in case a user wants to withdraw the funds and without completing all the tasks and everything. This is just a function that a user that the owner can call on the smart contract just to withdraw all the funds that they have deposited to it. So we're going to create a function called withdraw deposit safely. This is going to be a public function. Again, only owner can call this. And what this function is going to do is require. So what this is going to first do is require that the deposit is greater than 0, because we don't want to be able to call this function if there is nothing to withdraw. We'll then set the amount equal to the deposit, and then we will withdraw this. So we're going to do a payable. This is going to be the owner, and we're going to transfer the amount. So again, we are just transferring out back to the owner the deposit amount. We'll then set deposit back to 0 and emit the deposit withdrawn, which is going to be the amount. So that's going to be our withdraw deposit safely function. Again, this is just a safety function just in case the owner wants to withdraw their funds without completing all the tasks that were set. Next, we're going to create a function that checks if all tasks are completed, because we're going to have to check if all tasks are completed in order to transfer back the deposit. So we'll just do all tasks completed. Now this function is going to be private because we only need to use it within our smart contract here. And it is going to return a bool. So it's just going to let us know, are all the tasks completed? And if they are, then we will return true. So we're just going to use a for loop here and loop through our task. And if a task is completed, so remember our struct here, we have a bool that says if the task is completed or not. And we're just checking if the task is completed is true or not. If it is false, then we're going to return false. That means all tasks aren't completed. And if we can get through our loop here, then we'll return true, confirming that all of our tasks in our task array have been completed. Next function we're going to create is a clear task function. And what this clear task function is going to do is, once we check that all tasks are completed and we transfer back the funds, we want to make sure that we clear out the array of tasks. That way we can create a new one after that. So the clear task is just going to be a private function, and all it does is delete task. So essentially this is just going to clear out our array so that we start off with an empty array again. Our next function is going to be our completing task function. And for this, we need to know what task we are completing. So we're going to do uint256, and that is going to be our task ID. This is going to be a public function, but again, only owner function. Now we're going to require a few things first to execute this function. First, we need to make sure that the task ID exists. So we're going to do task ID is less than task.length, because if the task ID is greater than the length, it means that this task ID is not a valid ID. So we're going to make sure that the task ID that we pass through this function here is less than the length. We're then going to also require that the task is not completed, right? Because we don't want to be able to complete a task that is already completed. So we're just going to check that the task ID of task, we're checking the is completed is not completed. And we'll just, if it is completed, then we'll just say task is already completed. Next, we're going to set the is completed on that task to true so that we can mark that it is completed. And we will then emit that the task has been completed by passing the same task ID that we just marked as completed. What we're also going to do though is we are going to check if all tasks completed. And if all tasks are completed, then we are going to transfer back the deposited funds. So what we're going to do here is similar to what we did on the safety withdrawal. We're just going to set the amount equal to the deposit that we have in our smart contract. We'll then make a payable to the owner and transfer the amount back to the owner. We'll set deposit back to 0. We'll emit that there was a deposit withdrawn. And at the very end, we will clear all tasks and start with an empty array of tasks again, and the owner can restart creating a deposit and task. So again, just to go through the complete task function, we're checking that the task exists. So again, we're checking if the task exists. The second thing we're doing is making sure that the task isn't already completed. We'll then set the is completed on that task to true to mark that it is completed. We'll emit the event that it was completed. And after a task is completed, we'll check if all tasks are completed, which is our function that we created up here. And if that is true, we're going to set the amount to the deposit amount in our contract and transfer that amount back to the owner. We'll then reset the deposit back to 0, emit an event that a deposit has been withdrawn, and then clear out our task or clear out our task array. And that way, the owner of the smart contract can redo everything over again for another accountability goal or whatnot. So once we have our complete task, we're going to create a few more functions to allow us to get certain information from our smart contract. So the first one is we're going to create a function called getTaskCount. It's going to be a public and it's going to return us a uint256 here. And what it's going to do is return us the length of our task. That way we can see how much task we have. And in our application, we can do certain things. If we don't have any task, we can allow a user to create a task. And if we do have some tasks, then we can then list those tasks in our application. The next function is going to be getDeposit, which again is going to be a public function and returns a uint256. And this is just going to return our deposit variable so we can know how much has been deposited into our smart contract. And then the last function is going to be getTask, which is going to return our array of tasks. So this way, when we get our task, we can then map through it in our application and display all the tasks that are in our task array. And that does it for our smart contract here. So the next thing and the final thing we need to do here is deploy our contract. Now, deploying with thirdweb is very easy and it doesn't require you to import any of your private keys or anything. So it is a secure way of deploying your smart contract. So to deploy our smart contract, we'll open up our terminal here and we'll run npx thirdweb at latest deploy. And you can see here, it detected our project type, which we are using Foundry for this. It's compiling our project and building it, and it'll then upload our contract metadata to IPFS, and we'll be able to deploy this contract directly from thirdweb's website. So what you should see is a browser tab pop open, allowing you to deploy this contract through thirdweb. If you don't see the browser pop up in your terminal back where you ran the command, you'll see the URL link to head to that website. So once here, you can then select the network or chain you want to deploy on. So in the dropdown, you can select any EVM compatible chain from mainnets to testnets. You can search your chain here. For this tutorial and example, I'm going to deploy on Mumbai. So I'm going to hit deploy now. I'm going to confirm the transaction, and a second transaction will pop up, which is just a gasless signature that we need to sign in order to add our contract to our dashboard. So again, just sign here to add it to our dashboard. And once it's been deployed, you can see here that we are now in our contract dashboard. And over here, we can actually check out the Explorer tab. This is going to show us all the write and read functions on our smart contract. So if we head to the read section here and we click deposit, you can see right now we don't have anything deposited. We can also get task count, should show 0 as well, because we haven't set or haven't executed any of our write functions, which if we take a look, we can see we have our create task where we can put our description, deposit funds, so we can send whatever funds we want into our smart contract. So we can take a look at all of those here. So now that we have our smart contract deployed, let's build out our application. I'm going to head back to my terminal here, and we're going to create our app using thirdweb. So we're going to run npx thirdweb. I'm going to do @latest, and we're going to do create app this time, not contract. So we'll do create app. We'll name our project. So we'll just do Go app here. We'll select the blockchain that we want to use. Now, again, I deployed this on the Mumbai testnet, so that is going to be EVM. We'll select our framework for this tutorial. I'm going to use Next.js and TypeScript. And once that completes, we'll just switch over to our Go app. And now for this tutorial and video, I'm going to be using the Chakra UI library. This is just going to allow me to create a nice looking application with some pre-built components from Chakra UI. So I'm going to install that now. Now we'll drop a link down to the docs for Chakra in the description. You can install it and follow along as well. Or you can, again, always create your very own styling for your application. But I'm going to install Chakra here. And once that is complete, I'm just going to open this up in our code editor. So in our code editor here, the first thing we're going to do is under the pages folder, we're going to head over to our _app.tsx file, and we're going to set up our application here. So you can see the thirdweb provider here. This is our main component that wraps our application, which allows us to interact with the blockchain and our smart contracts. Now, it does need an active chain. So up here, we have our active chain variable, and we're just going to switch this to the chain, that we deployed on. So in my case, I used the Mumbai. So I'm going to set the active chain to Mumbai here. Now at the top here, I'm going to get rid of this styles because we don't need the styles here, because I'm going to import Chakra UI or Chakra provider to use in our application here. And I'm going to, within my thirdweb provider here, add Chakra provider, and that will wrap our components so that we can use some of the Chakra UI components within our application. So that does it for our _app.tsx file. With this set, we can start building out our application, and it'll be able to interact with our smart contract. Now in my file directory here, I'm going to create a new folder. Oh, not in pages though. Create a new folder. I'm just going to name this const for our constants, and we're going to add a new file called addresses.ts, and this is just going to allow us to store our contract address here in a variable and use it throughout our application. So I'm just going to export a variable called accountability contract, and we're going to paste our contract address in there. So I'll come back to our contract here, and in the top, we can copy our contract address, and we can come back to our code editor here and just paste that in. Right, so let's also open up our terminal here and run yarn dev, and this will give us our application here. Let's just open it up and see what we get. So at first, when you build your application with thirdweb, you're going to get a templated, some boilerplate code here. It looks a little weird because I overrid the global styling sheet with Chakra. So you can see it looks a bit wonky and weird right now, but we're going to get rid of all of this code here. We'll actually keep the connect wallet button, but we'll get rid of everything else. So back in my code editor here, I'm just going to drop this down. I can close out these. I'm going to open up under our pages folder, the index.tsx file. And you can see here, this is all the kind of boilerplate code that you get. I'm going to delete everything here. And the first thing I'm going to do is create a container, which is a Chakra UI component. And we're going to set the max width here to 1440 pixels. I'm going to delete the style sheet here. And in the middle here, we're actually going to create a flex so that we can center everything and add a connect wallet button inside of that. So the flex is just going to justify and align my content and items in the center, and the height of it is going to be 100 of the view height. So this connect wallet button should just be in the middle of our application. So coming back, we'll check out our app. We can see right here, let me just disconnect. We have our connect wallet button right here in the middle. We can connect to our wallets like MetaMask, and you can see we get all of our information of our connected wallet. So the next thing we want to do is display our application only if a wallet is connected. Now, to check if a wallet is connected, so what we'll have to do is check if a wallet is connected, and we can do that by using a React hook from thirdweb. So I'm going to create a variable here called address, and we're going to use the use address hook. Now, this use address hook is going to get the wallet address of a connected wallet to our application. And if it doesn't have a wallet connected, then this address is just going to be undefined. So we can use this one to get the wallet address of the connected wallet, but we can also use it to check if there is a wallet connected. So below our connect wallet button here, we're just going to create a box and give it a height of 20 pixels just to use it as a spacer. And next, we'll check if there is an address connected to our application. And if there is an address, then what we'll do is display we'll create it next, but we're going to do an accountability card. And this will be our application. We haven't created it yet, but what we're going to do next is create this accountability card. So in our file directory here, I'm going to create a new folder. I'm going to call this components. And in components, I'm going to create a new file and call this accountability card. And then .tsx. Spelled accountability wrong. And in this accountability card, we're going to create our accountability card component. Now, what we're going to be displaying in this card, we're going to need to get a few things first. So the first thing we're going to get is our contract. So we can get our contract using the use contract hook from thirdweb. And what this is going to allow us to do is allow us to retrieve our contract, and then we'll have the ability to start interacting with it. So let me just import the use contract hook here. And with the use contract hook, we need to give it a contract address. So we have our accountability contract that we stored in our addresses file. Next thing we're going to do is we're going to get the deposit amount. So we want to check if a user has deposited funds into their contract, because if they haven't deposited anything yet, then we shouldn't allow them to create tasks or anything yet. So what we're going to do is create a variable here. We're going to retrieve our data called deposit amount. We can also check is loading to make sure that we have retrieved our data here. And we're going to use the use contract read hook from thirdweb. And this use contract read hook requires two things. The first thing is the contract that we're interacting with, which is going to be our contract that we just got up here. And then the read function that we're going to be calling. So if we take a look at so if we go to our contract and under the Explorer here, we go to the read section, we're calling this get deposit function here, which is again going to return us our deposit amount that we have in our contract. So right here, we can get the function name, copy that. And in our use contract read hook, we can just paste that function. So again, this use contract read is going to use the read function get deposit from our contract and store that information in this deposit amount variable. Next thing we're going to do is we're also going to do the same thing, but for the task count, because we want to make sure that there are no tasks and that there is no deposit so that when we start off, we can guide the user through the steps that they need to do. So we're going to do data. We're just going to do a task count here. And we're going to do something very similar. We're going to use the use contract read hook in here. This is going to be on our contract. And we're going to now call this on our other read function. So we can check our contract here. Read, we're getting get task count. So we can copy that and then paste that back here. And that will give us our task count. So next thing we need to do is create our component here. What we're going to create is a card. Import this. It's just a Chakra component. It's just going to give us a nice card with a drop shadow. We'll set the width to 60%. We'll set some padding here to 10, and we'll make sure we text align and align everything to the center. We'll give it a heading here, and we'll call this accountability app. And we'll save that, and we'll take a quick look at our application here. Actually, we need to come back to our index here, .tsx, and import our accountability card. There we go. And then coming back to our app, let's connect our wallet here. And there you go. We now have our connect wallet button, and we have that card with our header here. You can see that there's a nice little drop shadow there. Let's actually fix this flex here so that it displays up and down. So we're just going to add a flex direction here. This should be column. So come back to our app, and there we go. We have our connect wallet here at the top and our card here, which is going to be the container for our application. So in our accountability app here, the next thing we're going to want to check is if there is a deposit amount and if there is a task count. And we want to make sure both of those are 0. And if they are 0, then we're going to guide our user through on depositing an amount and creating a task. So we're going to check that we have, we're going to check to make sure that is deposit amount loading and is task count loading. We want to make sure that we actually have that data that we can check first. If we don't have that data, we'll just show a spinner here from Chakra. And if we do have that data, we're then going to, let's create a box here. Box is kind of like a div. So in the box here, we're then going to check the deposit amount is equal to 0 and the task count is equal to 0. And if the deposit and task count are equal to 0, for now, we'll just add some text to say make a deposit. Let's just import this here. So again, if the deposit is 0 and our task count is 0, we're going to display them to make a deposit, but we'll just add some text there for the filler. And if they do have a deposit, then we're just going to create a stack, which is a Chakra UI component that allows us to just space everything real nicely on top of each other. So we can just set a spacing of 8. And in here, we're going to display, I just have a box, so like a div wrapping to text that says, that is going to display the goal amount. So this is going to be our deposit amount. Let me just import ethers here. So the goal amount is going to be our deposit amount. The deposit amount, though, that we get back from our contract is a big number. So we do need to format this into a readable number here. So we can do that by using ethers utils.format ether, give it our deposit amount in that big number, and it'll format it to a number for us. And that's going to be in Matic. And below that, we'll just say, we'll give a little description saying the deposit amount will be transferred back when all tasks are completed. So if we save this here and we head back to our app, it's going to say make a deposit because we don't have anything deposited yet. What we can do just to test this out, though, is we can come to our contract. We'll go right, we'll go deposit funds, and we'll just deposit 0.01 tokens. So we're going to call this function directly from our smart contract here, just so we can see it within our application. So we'll execute that. You can see here we're sending that 0.01 Matic. We'll confirm that transaction. And you can see here that our transaction went through. We deposited our 0.1. If we come back to our read and get deposit here, you can see that this does not look like 0.1, but this is in way here and in a big number format. So again, that's what this ethers.utils.format ether is doing. It's just going to format it so that when we come back to our app, you can see we have a 0.01 showing. So again, this is now that we have something deposited, it shows that we have our deposit amount here of 0.01 Matic with our little description down here saying that it's going to be transferred back once all tasks are completed. So we know that we can display information that once we have a deposit, but we want to make sure that our user can make a deposit within the application and not have to go through the smart contract to do so. So we're going to create a component for our user to make a deposit here. I'm going to create a new file in components and call this deposit.tsx. And we're going to create our deposit funds here. And I'm going to first create, and what we're going to be doing is creating a little input field and button that will allow a user to input the amount they want to deposit, and a button that is going to then call the function from our contract and deposit that amount. So here I'm going to create a state variable for our deposit amount. We'll set it to 0 by default. And then in our app here, I'm going to create a stack, give it a spacing of 8. And at the top, we'll create a box, give it a margin top. Oops, let's import box first. We'll give that box a margin top of 10. And then we'll add some text in here that says you don't currently have a goal set and that you have to deposit funds that will be transferred back to you once your tasks are complete. Below that, we'll create another box here and create our input field. We'll create some text that just says deposit amount, so it labels our input field. And then we'll create an input field here. And this input field, we're going to have a placeholder that is going to say, not enter amount, but 0.0. This type is going to be a number. The value is going to be the deposit amount. And then we're going to do on change here. And what this is going to do is take our event of a change, and we're going to set deposit amount to our target value, as a number. Right, and that should give us our input field. So if we come back to our app here, actually, we still have that amount deposited. So if we come back to our contract here, we can go to the right function and we can use that withdraw deposit safely. Remember, this function automatically is going to withdraw any deposited funds. So we'll just execute this function here from our contract, confirm that. And you can see that went through. So if we read our get deposit now, we now have 0. So now if we come back to our app here, it'll have that make a deposit again. And we can, in our deposit here, make sure that we get rid of this text and instead we'll show our deposit funds. So you can see here we have our little input field where we can input our deposit amount. So once someone inputs a deposit amount, we want to make sure that we have a button here that allows them to deposit this to the smart contract and call that smart contract function here for deposit funds. So in order to do that, we'll come back to our app. In our deposit.tsx file, under our input here, we're going to create a Web3 button. We're going to create a Web3 button, which is a UI component from thirdweb. Basically creates a button that allows us to interact and call functions from smart contracts. So we can just say, we'll name this deposit to start. Now our Web3 button requires a minimum of two things. The first thing is going to be the contract address. So we're going to be calling this function on our accountability smart contract. And then we're going to need the action, which is the action that this button is going to be doing on top of the smart contract. So for this button here on our contract, so we can call a function on our contract, and in here, so we can do contract and we can do call. And this will allow us to specify what we want to call. So the first thing we need to do is put the function name that we're going to be calling, which is deposit funds. The next thing that it's going to do is take any arguments in an array for that function. This function doesn't have any arguments, so we're just going to give it an empty array here. And then because this function is a payable function, we need to specify the amount that is going to be transferred in here. So what we'll do here is then add the value of what we're going to be sending, which is going to be our deposit amount. But because we're entering the deposit amount in a regular number format, so like 1 or 0.5, we need to make sure that we give this amount in way, which is the units that is going to be taken by our smart contract. So similar to how we converted our big number way to a regular number, we now need to convert our regular number the opposite way to a way amount. So to do that, we can again use ethers.utils. And this one we're going to do parse eth. And this is going to need to take a string of our amount, which is going to be our deposit amount. And we'll just use the toString to give it a string value. And that here is, again, how we're going to call the deposit funds function from our smart contract using the Web3 button. So in our app here, you can now see we have our input field and we now have that deposit to start button. So we can deposit amount. Let's just say 0.02. We can hit deposit to start. We'll get a transaction that pops up. You can see here that we're sending the 0.02 Matic. We'll confirm that transaction. And there you go. You can see our application switched. So we have a goal amount now set to 0.02 Matic. Now the next thing we need to do is show the ability to either create tasks or display the tasks that we have in our smart contract. So coming back to our code editor here, we're going to create a new component called task. So we'll just call this task.tsx. And in here, we're going to create this task component that is going to display one of a few things depending on the amount of tasks that our user has in their smart contract. So first thing we want to check is there any tasks that exist? Because if there are no tasks, we're going to prompt our user to create their first task. So to do this, we're first going to get a few things in our task component here. We'll first get our contract again, and we'll use that use contract hook using the accountability contract address. We'll then need the task count again to check if there are any tasks. And then we'll use the use contract read hook, reading it from our contract and reading the get task count. Import to that. Now, if the task count is 0, we're going to prompt our user to create their first task. To do this, we're going to have an input field so that they can enter in the task that they want to create. So I'm going to create a state variable here for first task, and we're going to set the first task just to some empty string here. And then if they do have task, we want to be able to display that task. So we're also going to get the data of our task here. And then we're going to use the use contract read function. And then we're going to use the use contract read hook again on our contract. This time we're going to be getting our task. So if we take a look back at our contract here, we're going to be reading and we're going to be calling this get task, which is going to give us back the array of tasks that we have. So in our task component here, we're going to create a stack here. Again, a stack just allows us to stack everything nicely upon one another. And in our stack here, we're first going to check and make sure that we have our task count because we don't want to display anything until we have that count. So if we don't have our count yet, we'll just show a spinner again. And if we do have the count, then what we're going to check is, does task count not equal 0? Because if there are some tasks, then we're going to display those tasks. But if there is no task, then we're going to prompt a user to create a task. So in here, we'll create another stack. And I'll just add a stack here so that we can view our app after. So again, if the task count is equal to 0, we're going to prompt that our user create their first task. Let's import that. And what we're going to do is give them an input for their task here. And this input will have a placeholder of your first task or first task. Type is going to be text. The value is going to be first task. And we're going to on change set first task to whatever the value of this input is. So if we save that and take a look at our app, we actually need to make sure that we put this task card in here or into our deposits. So we're actually coming back to our app and our accountability card. We have deposit funds and then we have our goal amount. So right over here is where we'll put our task. Save that, come back to our app, and we're still getting a loading spinner here. So if we come back to task here, what are we checking? We're making sure that the task count is not loading. So now we'll come back to our app here. There we go. We have create your first task, and then we have our little input here. So once someone puts in their first task, so let's just say first task, we want to make sure that they have a button here that, again, calls that create task function from our smart contract and adds this task into our array of tasks in our smart contract. So coming back to our task component here, under our input, we're going to create a Web3 button again. That Web3 button is going to just say create task. And again, that Web3 button requires those two things. First thing being contract address, which is going to be our accountability contract, and then the action. Again, our action, we're going to call a function from our contract. So in call here, we're going to call the function create task. So if we take a quick look here back at our smart contract and we go to write, we're going to be calling this create task function. Now this create task does take one thing, which is our description or our task. So we need to make sure that we pass this into our arguments here so that we know what to give to our description argument for our function. So coming back to our code editor here, we're going to be calling the create task. And then we need to create the arguments here, which is going to be an array of the arguments. But we only have one here, which is going to be the value of whatever is in our input here. That is what we're going to pass through to our task. So coming back through our app, we can just say build accountability smart contract is our first task. We can hit create task. We'll confirm that transaction. And there you go. You see we have a blank here because if we come back to our code editor right here, if the task count doesn't equal 0, we're not displaying anything right now. But we can also check our smart contract. Come to the read functions here. We can get task count. You can see we have 1. We can also get task. And this is going to pass us back the array of tasks that we have in our smart contract. So now that we have one task in here, let's create a task card so we can display all of our tasks and create a function to add more tasks if we need to do so. So back here, right here in this top section where we're checking and displaying this stack here, if our task count does not equal 0, here we're going to check to make sure that is task loading is done. Right here, this is task loading is checking to see if we have our array of tasks loaded for us. If it is still loading, we will show a spinner. But if it is done loading, we're going to take our task. So we're going to map through them and we're going to map, which is going to give us a task, which we're going to set to any here, and an index, which is going to be a number. And in here, for each one of those tasks that we map through, we're going to create a task card. So we're going to create those task cards now. So coming back into our components folder, we'll create a new file called taskcard.tsx. Now this task card is we're going to create some type props here because we're going to need a few stuff to create these cards. One, we'll need the task ID, which will be a number. We'll need the actual task, which will be a string. And we're going to need to check if it is completed or not, which is going to be a Boolean. We'll then create our component here. Now, depending if our task is completed or not, we're going to change the color of it. So we're going to make it green if it's completed. And if it's not completed, we'll just leave it at its own default color. So we're going to set some variables for the background color, border, and font color. By default, it's going to be white with some gray border and gray font color. But if our component or our task is completed, we're going to change those things to these green colors and values here. We're also going to create a toast, which is going to be that little pop-up at the bottom of our app when a task is completed. So for this task card, we're going to create it as a card component. This card is going to have some padding of 8. It'll have a background color of background color. It'll have a border. This is going to be a 1 pixel solid border. And it will have a border color of border color. So again, the background color and border color we're getting from our variables that we have set up top, depending if it is completed or not. In here, we're going to then create a flex with a flex direction of row, and we're going to justify the content with space between. Make sure we import this. And we're going to align items to the center as well. So within our flex here, we're going to show our task. So we'll just show some text here with our font. Make sure we import our text. This text is going to have a font weight of bold and the color of font color, depending if it's completed or not. And what this is going to show is our task. So if we save that and our task, we're going to, in here, again, map through our different tasks. So for each one, we are going to display a task card. And again, the task card, one will set the key to the index, we'll set the task to task, the task ID to the index, and the is complete to task.completed. So coming back to our application here, you can see that we see our one task that we created, which was the build accountability smart contract. Now we want to display a little button here that allows us to mark when we have completed that task. And we also want to show completed if a task is completed, along with a add task button at the bottom here so we can add more tasks. So actually, let's create that add task button here first so we can add a few more tasks to our list. So in our components folder, we're going to create a new file, call this add task button.tsx. And we're going to create that add task button. So for this add task button, we're going to create a button that opens up a modal over our application to add more tasks. And what we're going to do is create a modal using Chakra. So to create a modal, we do need this is open, and on close here. We're also going to create a toast using Chakra, and we're going to set our state variables here to task and set task, similar to how we did the creating our first task one. This is going to be for any additional task though. So right here, all our component is going to do is it's going to be we'll wrap it in a box, and we're going to have a button that says add task, and on click, it's going to open the modal. So let me just import this here, import this button as well. And the modal that it's going to open, we'll just paste in here and import everything really quick. So for this add task button, we're going to create, again, this modal that overlays our application. This modal code here, you can actually get it directly from Chakra's documentation. So if we come over to Chakra UI components and we look for modal, you can see here, you can take this modal example that they have and then fill it in with the information that we need, which is what we did here. So again, we just have a button that's going to show add task. When that is clicked, the modal will open here. The header of that modal is just going to say add task. In the body of this modal, we're going to have a stack and have it prompt a text that says add task to your accountability list, saying that all tasks must be completed to receive your deposit back. And then we'll have a text and input field that says task. The input field is going to be where they can input their next task that they want to add. So again, similar to like how we did the first task, the placeholder is just going to say your task here. The type of this input is going to be text. The value is going to be set to task. And on change, again, we're using this state variable up here to change and set task to whatever we have in our input field. Down here in the footer, we're going to add another Web3 button. And again, that Web3 button is going to call that create task function from our smart contract. And we're going to pass the argument of our description, which is going to be the task that we inputted into our input field. Now with this, we're going to add a toast here, which means which is that little pop-up that we're going to show confirming that a task was added. We'll go through and show you that once we run this in our application. But in a Web3 button, we can also set an on success. So this means if the transaction goes through, what do we want the application to do? So one, we're going to have it close the modal. So we can use the on close here. We're going to actually have it set task back to empty so that if someone adds another task again, they're brought back to an empty input. And then we're going to show the toast here, which is going to be a Chakra UI component, but we're just going to confirm that a task has been added and that we're going to show status is success. So it shows green, and then we'll make it closable as well. And that is just going to be an add task button. So if we come back to task here, and we come right under where we're checking is task loading, we're going to add our add task button here, save that, and then come back to our application. And you can see we now have this button that allows us to add a task. It'll pop up this modal here where we can add more task, and then that Web3 button. So again, we can do a build accountability app. add that task. We can then confirm that transaction to add our new task. Again, once this completes, it's going to close out our modal, close out our task input here, and show us that little toast pop-up saying that our task has been added. So you can see here, task has been added. And if we hit add task again, you can see our input is blank and you can add another task. And we'll add another task here saying this is the final task. We'll add one more. Cool. And then you can see we have our 3 tasks here that we have just added. So again, now we want to go back into our task card and add a little checkbox so we can mark them as complete. And we also want to give the ability to change them and their color to a green color so that we know which ones are completed. So coming back to our code editor, we're going to head to task card again. And what we're going to do here is under our text for our task, we're going to check is completed. Because if it is completed, what we're going to display is just some text that says completed. So we're going to show text with the font weight of bold. The color is going to be font color, and it's going to show completed. Now, if the task isn't completed, this is where we're going to show a Web3 button. And this Web3 button will just have it display a little check mark. And again, that Web3 button is going to be interacting with our contract address for our accountability contract. And the action that this is going to be taking is it's going to call the complete task function. So if we take a look at our smart contract again, go to write, complete task. We need to give it the ID, the task ID that it is going to be completing. So coming back to our code editor here, we're going to give it past the array of arguments here, which it's going to take is the task ID, which are getting from our props for this component. Then similar to the Web3 button that we did for adding task, we're also going to add on success. This one is just going to say your task has been completed and that we have completed the task. So if we save this here, come back to our application, you can see we have now check marks next to our task cards next to each one of these tasks. Now we can make these a little bit smaller as well. So with the Web3 buttons, you can override their default styling and classes. We can just give this a class name. We'll actually import here our styles from I think home module. Yeah. So we can import our styles from the style sheet that we get when we create a third web application. And then we'll give this a class. And then we'll give this a class name of complete button. And then what we can do is in our file directory here, we can come under styles, go to home module.css here, and we can add some of our own custom CSS here. So we can say minimum width, we can make this 48 pixels, and then we'll also make the max width 48 pixels as well. Now, when overriding these default styles for third web components, you want to make sure you add the important to override those there. So coming back to our application here, you can now see we have these little checkboxes. So now we want to make sure that when we complete one, that we get the green completed card instead of this card that needs to be completed still. So remember in our task card here, when it is completed, it is going to switch over all the colors to the green colors here, and it is just going to show some text that says completed. So we'll complete the first one here. We'll confirm that transaction. And we completed the task, but we still don't have that checked off. So let's take a look at our code editor here. We'll have task. And I believe this is completed is supposed to be is completed like that. So now if we come back to our app, yep. You can see that we now have a completed card here because this card is completed. We now have a completed card. We now have a completed card right over here. So this pretty much does it for our application. Now we can check to see if the funds are refunded back and transferred back to the owner wallet once all tasks have been completed, and our application should reset back to the beginning where we can make another deposit. So let's run through this application fully and to make sure it works. So we'll check off all these tasks here. You can see we checked off that last one. And now when we complete the final task, we should get our 0.02 Matic back. So right now we're standing at 1.03 Matic. Let's complete that last task here. And there you go, we completed the last task, and you can see our app is now reset back to the beginning. We don't have any current goals set, and we can make another deposit again. So let's run through this again here. We can do let's do 0.5 this time. We'll deposit that. You can see we now have a goal amount set to that 0.05 Matic. So we can now create that first task again, confirm the transaction. And there you have it. We have our first task. And again, we can complete that first task here. If we actually were to complete this one and only task, we will be refunded back our 0.05 Matic. But there you have it. We created our very own accountability app, which allows a user to deposit some funds, create a task list, and the only way to get those funds back are to, again, complete the task that they have created. We built our very own custom smart contract that takes care of all of this, and our very own front-end application that makes interacting with the smart contract nice and easy. And again, links to all the things that we've done in this tutorial will be down in the description below. And don't just stop with the features and abilities that we added into our smart contract in this tutorial. Grow it out a little bit more, add your own features, share it with us on social media or in our Discord channel. But again, I hope you folks enjoyed this video. If you did, give this video a thumbs up, hit that subscribe button, and don't forget to turn on the notification bell so you don't miss out on more tutorial videos just like this. If you folks haven't joined our Discord community yet and joined the amazing community of builders just like yourself, we'll add a link down in the description as well. If you need any help or support, you can drop it in our Discord and we'll be happy to help you out. But again, I hope you folks enjoyed this video, and until next time, see ya.